Hello everyone, and welcome to this education tutorial on SNOMED CT in the electronic health record. My name is Højen. I'm a member of the education and product support team here with SNOMED International. I will be chairing this session, and as you will hear, I will also be doing the presentations, which you will see shortly. And together with me is my colleague, Ian Spires, and he's going to help answer questions. So Ian and I will be here to answer any questions you have during this session. So please don't hesitate to raise any questions using the Q&A box in the bottom of your window. I hope that you are enjoying the SNOMED Expo so far and have found your way around the Expo conference site. I also hope that you have had an opportunity to listen to some of the great presentations that have already taken place. So now I'll just show you the outline for this session. So for the next 90 minutes, we will be exploring the role of SNOMED CT in the electronic health record. So that includes in the information model, in the user interface, using SNOMED for storage and exchange. So we've divided this session into 3 parts. So first, you will see a presentation on the general role of SNOMED CT in the electronic health record and some of the best practice principles for using SNOMED CT at the user interface. Then we will have a short Q&A question, so just to cover some of the questions that may have come in during the first presentation. And after that, we will watch a demonstration where where we will demonstrate a tool that shows some of these best practice principles for entering data into an electronic health record. Then in the final part, we will show you a third presentation, which is on the best practice principles and the considerations that are for storage and exchange with SNOMED CT. And then at the end, we will have we'll cover some of the questions that have come in around that topic. So for now, it's time for the first presentation. So please lean back, and then I will start the first presentation. And as I said, enter any questions you have while the video is running. That is perfectly fine. Enjoy.
In the first part of this presentation, I will introduce the general role of SNOMED CT in the electronic health record. In recent years, a key focus of health record development has been converting them from paper records to electronic health records. This has been a significant step forward, as it opens opportunities for improved communication and improved availability of relevant information, because a patient record can be accessed in many places and is no longer vulnerable for loss in transit between clinics and wards. But this is only a partial solution, because the real challenge now is making electronic health records meaningful, allowing us to identify significant facts in oceans of data, enabling effective meaning-based retrieval, and linking the electronic health record to clinical knowledge to enable integrated clinical decision support. The ability of SNOMED CT to represent clinical meanings contributes to the development of meaningful health records to address this key challenge and facilitate the delivery of these benefits. If we consider the different elements of an electronic health record, it becomes evident why a single clinical terminology that is enabled to encompass the various types of clinical information that may be captured in an electronic health record needs to be both broad in its scope and support high expressivity in terms of granularity. For clinical care, we must include the fine-grained details needed to direct and manage practical care. For example, a surgical procedure might be described as the amputation of the distal phalanx of the second forefinger. For reporting, a much less detail is required, probably no more than amputation of finger or part of finger, or perhaps just operation on hand. In this slide, I've illustrated just some of the common parts of an electronic health record. Examples of coded data items include elements for capturing patient diagnosis, procedures, clinical findings, tests, results, social circumstances, required follow-up, care and therapy, medication and medical history. Bearing in mind the scope and detail of medical knowledge and the objective of SNOMED CT to represent clinical meanings accurately and unambiguously, it becomes a natural characteristic of SNOMED CT that it's not just a coding system of diagnosis, but it covers the broad scope of clinical meanings that is relevant to record in clinical records. This means it also covers other types of clinical findings, like signs and symptoms. It includes tens of thousands of surgical, therapeutic and diagnostic procedures, and it includes the observations which clinicians may perform. SNOMED CT also includes concepts representing body structures, organisms, substances, pharmaceutical biologic products, physical objects, physical forces, specimens and many other types of information that may need to be recorded in and around the health record. These different types of clinical meanings are represented by unique concepts, organized in a series of top-level hierarchies. And this comprehensive scope of SNOMED CT reduces the need to support multiple, incompatible or overlapping code systems in the same health record system. It also means that SNOMED CT can act as the common terminology for consistent communication, retrieval, and processing across clinical specialties and between healthcare facilities at local, national, and international levels. And having a clear understanding of these hierarchies and the various types of clinical concepts within these hierarchies is very important when implementing SNOMED CT in a clinical record. Because generally, each of these data items in an electronic health record can be linked to one hierarchy or sub-hierarchy in SNOMED CT. In some situations, multiple hierarchies or alternatively concepts with very specific characteristics may be valid for specific data items. For example, when recording a diagnosis, only concepts from the clinical finding hierarchy is used, while procedures are recorded using concepts from the procedure hierarchy. And when you link a data item to a specific set of values acceptable for that data item, you are performing the kind of terminology binding which we refer to as value set binding. Value set specifies a set of codes that can be used in a specific context or data item. And as shown in this slide, a SNOMED CT value set may be specified intentionally using an expression constraint, such as the descendants of disease, but it may also be specified extensionally, as exemplified here, where you have enumerated a specific set of concepts to be included in a social circumstances subset. What we gain from this type of terminology binding is an assurance that data recorded in that particular data item is represented by a SNOMED CT concept that semantically is within the scope of the specific data item. Or said in other words, we ensure that you would never use a procedure concept to represent a diagnosis. In this slide, we're going to look at a high-level system design for an electronic health record system, which shows the interactions that may occur between various system components. Electronic health records are usually designed with both a health record data store to record health-related information about each patient, and a terminology data store to record the codes and terms that may be used in the health records. In the health records, data is entered by the user using the terms presented in the user interface and stored in the health record data store. These records are then searched and retrieved by users and displayed once again on the user interface. The data recorded in both the health records and the terminology can be queried and compared with decision support rules and clinical guidelines to determine appropriate messages and information to display to the user. Health records data may also be extracted into a data warehouse or similar secondary data store, and queries can be executed over the data to generate reports and perform various analytics functions. And lastly, communication can occur in which health records are exchanged with other systems or applications. And we won't be able to dive into all areas of SNOMED CT in the electronic health record design in this session, but we are going to cover SNOMED CT for data entry and display, and later we'll review the principles of using SNOMED CT for storage and exchange. So let's continue this presentation with exploring the different options and aspects of SNOMED CT in the user interface. When considering SNOMED CT at the user interface, it involves both data display, which includes the approaches to render SNOMED CT on the user interface, and the terms to be displayed for the user. Furthermore, it includes data entry, which involves the techniques supporting the coding of clinical data with SNOMED CT. In the following slides, I'll introduce some of the key approaches to the display of SNOMED CT on the user interface. As a background information to this topic, please consider this definition of a clinical interface terminology, which is a systematic collection of healthcare-related phrases that supports clinicians' entry of patient-related information into computer programs. Interface terminologies are generally designed to enable human interaction with structured concepts, and they therefore provide the interface between a clinician's colloquial conceptualization of their clinical ideas and the more structured coded internal data elements used by specific healthcare applications. They also facilitate the display of patient information to clinicians as simple human-readable text. In general, clinical interface terminologies embodies a rich set of user-friendly phrases. There are a number of requirements for an effective clinical interface terminology. Firstly, an interface terminology requires a sufficient synonym coverage to represent the variety of colloquial phrases used in medical settings. This may include alternate phrases, such as dyspnea and shortness of breath, and acronyms such as SOB for shortness of breath, and definitional phrases such as a sensation of not getting enough air during breathing. Synonyms can be used to improve the usability of a system by increasing the ways in which the user can express themselves. At the same time, however, caution must be taken that this doesn't increase its ambiguity. Each synonym can be evaluated using two metrics. Firstly, expressivity indicates how well the synonym matches the words in the phrase that defines the meaning of the concept. And secondly, the accuracy of the synonym is how well the meaning matches the defining phrase. Here is an example of a term that has fairly low expressivity, but may have high accuracy within a given context. A fundus is the part of a hollow organ that is furthest away from the opening. But there are many different organs that can have a fundus, and sometimes it depends on the clinical setting as to what is the intended meaning of this term. For example, a gastroenterologist is likely to be referring to the gastric fundus structure, while an ophthalmologist is likely to be referring to the structure of fundus of eye. And a gynecologist is likely to be referring to the structure of fundus uteri. So this example shows the importance of understanding the context of the clinical setting in order to correctly map a term from the interface terminology to the correct meaning in SNOMED CT. The next requirement is that a clinical interface terminology requires an effective balance between pre- and post-coordination. Clinically useful phrases may be pre-coordinated in the interface terminology, even if they correspond to post-coordinated SNOMED CT expressions. However, excessive pre-coordination in the interface terminology should be avoided in favor of using separate phrases for different parts of the meaning. When we refer to excessive pre-coordination here, we are referring to any pre-coordination that leads to undesirably long lists or inefficient data entry as determined by the users. Like you can see in this example list here, where the pre-coordination of different types of injuries on a limited set of body structures can lead to a fairly large list of phrases, which may be difficult for the clinicians to navigate. Alternatively, it may be more effective to allow terms representing the different morphologies, body structures, and laterality as individual interface terms, which may then be combined or post-coordinated to form the desired meaning. Regardless of which approach is applied, the clinical phrases shown on the user interface correspond to specific SNOMED CT expressions or pre-coordinated concepts, which can be stored and used for subsequent retrieval and analysis. The last requirement of a clinical interface terminology is to be able to be accurately mapped to concepts in a more formally defined clinical reference terminology. This is needed to support the storage, management, and in particular the analysis of the clinical data. As we also saw in the previous examples, the clinical phrases shown on the user interface correspond to specific concepts or expressions in the reference terminology. Having covered what we mean when we say interface terminology, let's now explore three approaches to interface terminologies with SNOMED CT. Firstly, using free text with natural language processing. While this isn't a terminology in the strict sense, it's a valid interface approach, so we'll consider this here for that reason. Secondly, you can use a library of clinical phrases that is subsequently mapped to SNOMED CT. And thirdly, you can directly use SNOMED CT descriptions as the interface terminology. Natural language processing enables a computer program to analyze and extract meaning from human language. The extracted meaning from the NLP algorithm can then be represented as SNOMED CT concepts and expressions in a clinical record. Let's look at an example with a sentence going like this. Endoscopy revealed an acute gastric ulcer, but no evidence of gastric bleeding or perforation of the stomach. The resulting SNOMED CT expressions derived from this sentence is, firstly, endoscopy revealed leads to the procedure with explicit context expression, with the associated procedure being endoscopy. And the text acute gastric ulcer leads to the situation with explicit context expression, with the associated finding being acute gastric ulcer. No evidence of gastric bleeding leads to the situation with explicit context expression, with the associated finding being a nested expression representing a bleeding in the stomach structure with a morphology of hemorrhage. Also note how the finding context here correctly is stated as known absent. Similarly, the sentence, no perforation of the stomach leads to the situation with explicit context expression, with the associated finding being perforation of stomach, and again a finding context of known absent. Although NLP provides an easy and flexible way for clinicians to document the clinical situation, with the exact words and phrases they prefer, this technique shouldn't be used without caution. Processing free text requires the consideration and handling of abbreviations, spelling errors, grammatical errors, unexpected synonyms, unusual vernacular phrases, hidden contextual information, and many other linguistic challenges. It's therefore important that when using NLP for safety-critical purposes, it should always be accompanied by some level of human validation. The next approach to interface terminologies with SNOMED CT is to use what we call a library of clinical phrases. In this approach, a library of clinical phrases, or a set of clinical phrases, that is independent of SNOMED CT, is used as the interface terminology, and then these phrases are mapped to SNOMED CT and optionally other terminologies as well. The mappings to SNOMED CT may be either broad to narrow for one-to-many maps, or narrow to broad for many-to-one maps, or equivalent for one-to-one maps. And as you can probably imagine, the ideal situation is to find equivalent one-to-one maps, because this ensures that the complete meaning is captured by the SNOMED CT concept, and therefore queries performed over the resulting SNOMED CT concepts are as accurate as possible. The last approach I will mention in this presentation is using the SNOMED CT descriptions of SNOMED CT concepts as the interface terminology. This involves translating SNOMED CT and creating the required descriptions with terms required in the given language or dialect. The benefits of directly using the terms from SNOMED CT on the user interface are that no mapping is required from the clinical phrases to the clinical meanings, because that's already done as part of the SNOMED CT design. And the clinical intent of a selected term can be confirmed using other terms that are linked to the same concept. The equivalence of the terms to the clinical meaning is ensured by using quality authoring processes. There are standard mechanisms provided by SNOMED CT for distinguishing acceptable and preferred terms in different clinical contexts, and where appropriate, the standardization of preferred terms can improve patient safety, particularly in areas such as medication management. The only disadvantage that we can think of to this approach is that new SNOMED CT descriptions may need to be added to support the rich variety of language that may be needed. For example, a translation into a non-English language may be required, or additional synonyms may be needed to support the clinical context in which it is being used. This process of creating new SNOMED CT descriptions requires effective quality processes for authoring, reviewing, and releasing a SNOMED CT extension, whether this is done by a national release center, by a software vendor, or by another organization who has applied for and received a namespace from SNOMED International to enable them to create new SNOMED CT content. Now that we've explored the approaches to interface terminologies with SNOMED CT, let's take a look at some of the best practice techniques for coding clinical data with SNOMED CT, and the techniques that can be applied to support effective data capture. But first, a few words about the requirements for clinical data capture. Because clinical data begins with data capture, and this needs to be quick and easy so that it doesn't delay or interfere with patient care, but instead is an integral part of clinical practice. It also needs to be appropriate to the context in which it's collected and the purposes for which it will be used. And the data captured must be accurate and unambiguous so that the captured data can be effectively reused. Meeting those requirements demands for appropriate data entry methods, but the appropriate methods vary according to the working practices of different health professionals. Data entry is not one size fits all. What works for a family doctor or community nurse is unlikely to work for a surgeon in the operation room, or radiologist reporting his or her interpretation of the results of an imaging study. However, requirements for different data entry methods must not be allowed to undermine the consistent representation of the data collected, because that consistency is essential for effective communication, retrieval, and analysis. Therefore, since different care environments have different working practices, approaches to capture of data need to be adjusted to meet these requirements, even if the data collected has a similar underlying meaning. And while tailored approaches to data entry are necessary, these should not dictate the way that data is stored and accessed for reuse. So, having outlined the underlying requirements, let's take a look at some of the different methods that can be used to enter SNOMED CT encoded clinical information. As the general approach, we recommend to use structured data elements for key clinical data, for example to record the diagnosis, procedures, or allergies. Different controls may be applied to assist effective data capture, such as coded text fields, checkboxes, radio buttons, and selection lists. We'll explore each of these controls and how they can be used to capture data with SNOMED CT. However, the general approach is to bind the options in these controls to SNOMED CT concepts or expressions, to allow the data entered to be exactly the same as those that would have been entered following a successful search for appropriate concepts. But let's now explore some of these different controls. When determining what controls to use in a user interface, it's a good idea to consider the number of options that should be made available through the control. A coded text field is a typical text field or search field in which you can type a text string, which is then matched against a specific range of SNOMED CT concepts or expressions, using dedicated search techniques. I'll get back to these techniques shortly, but what is important to note here with coded text fields is that this type of control is useful for most structured data entry, but it's recommended in situations where you have a larger value set than is feasible for display in a simple drop-down. If you consider the example where we want to record data about a family history of a patient, you can imagine typing something like fam his A, and the system will then return concepts with descriptions matching the search string. The behavior of this search and the display of the search results is determined by the applied search techniques. As we have already discussed, SNOMED CT contains concepts representing different types of information, and concepts of different types are interrelated and often contain the same words. So while the breadth of content is a big plus for SNOMED CT, it can be less helpful when searching the terminology for data entry purposes. So what this means is that when using searches for data entry, the searches must be constrained. And the best practice technique for effective searches therefore include binding each data element to a specific subset of SNOMED CT, and then constrain the searches to only concepts within this value set. Specific recommended search techniques include using word prefix any order searches, which is where you allow results to match a different order of the search strings, and real-time searching, where results are displayed as the user types each letter. Indexes should also be applied to improve search speed, and searches should be performed over all acceptable synonyms for concepts in the value set. Regarding the display of search results, only display the preferred term for each matching concept, and order the search results rationally by shortest matching term first and according to frequency of use. Alternatively, rather than searching, a drop-down list may be used to display the options in a value set. This technique is useful for smaller value sets, and sometimes drop-down lists may also apply the search techniques that I just mentioned. Checkboxes are useful where simple yes-no answers are possible to a series of questions, like in this example, where there is a particular section or form into which family history is entered. In such cases, the context of this data as being related to family history is already known as specified by that section. It may therefore be possible just to tick a checkbox that says the word asthma in order to record that the patient has a family history of asthma. When implementing SNOMED CT with a checkbox interface, each checkbox needs to be bound to one or more SNOMED CT concepts or expressions. If only affirmative values are required, then each checkbox can be linked to a single concept or expression. I will talk more about the options for storage in the next part. As for checkboxes, radio buttons may be used for simple questions or very small value sets. Radio buttons are particularly useful when the absence of specific findings is required for recording, but only because this is made explicit on the user interface, as shown in this slide. Now we've reached the end of the first part of this session, where we have covered the different options for SNOMED CT on the user interface. The key point is that there are many ways to capture the same information, but there are techniques which can be applied to support the effective display and capture of clinical data for specific clinical situations using SNOMED CT.
Hi everyone. So that was the first presentation where we covered some of the best practice principles for data entry. And as you could hear, there's really not a constraint of the types of controls you can use when you capture patient data with SNOMED CT. And as I can see from your some of the questions that have come in, you are also one step ahead this presentation, because you're thinking very much about how to store data and what are the elements that should be stored. We had a question earlier about what we recommend to store, and that will be covered in the last part of this session, where we will talk about some of the principles, remembering to store the concept ID, but also the terms displayed and so forth. So we'll get back to that. Ian, what else do you see have come in here?
There was a question about using ECL to generate lists, and I think that has been answered. Just to say that I think a lot of lists are still created through cherry picking, but obviously ECL is a very strong way of creating lists, but it really depends on the reference set that you're using in the first place. If it's across a whole hierarchy, it might be easier to use a bit of ECL on it, but in truth, it really depends on the reference set on what's best to use. Either method works. The beauty of using ECL is that when it comes to a new addition to SNOMED is released, you can use that ECL query and see what items have disappeared and what have appeared due to additions within SNOMED CT. So it is quite powerful to do that. I think currently people do a mix of them, and a lot of the time it's done nationally as well, because a lot of time people use national reference sets within their vendor systems. One of the questions came in about observable entities. So the question was, would you use an observable entity in the title and then use finding codes to code the specific findings?
Yeah, I interpreted that question about whether or not when you implement SNOMED CT, whether you always have to use the observables represent the meanings and the findings for the results. And it's not a rule that you have to perform both the model meaning binding or the use of the observables and also the value set bindings, so where you represent your subsets or value sets using SNOMED CT. You can choose to do either or. It really depends on your use case and how you want to be able to retrieve data afterwards, whether or not you always have the meaning of the information model represented using observables or other concepts, and you then have the value sets represented using SNOMED CT value sets. It's not that you have to do both always. It depends on your implementation. You can choose to only use SNOMED CT in some parts of your system, in some specific value sets, and you can also choose to do a complete implementation of SNOMED CT where you use it both to represent the observations and the results of your of the observations. So I hope that answers the question. So it's not, you can do it, but you don't have to do it all the time.
And I think as well, if you have something that's quite a variable attached to the observable, you're not going to have findings for every particular thing, especially if it's a numerical value. So there are some cases where you just don't pre-coordinate all the finding options because there would be just so many for people to choose from. In those cases, you definitely use an observable entity and put a value against that observable entity. So you may not find all the findings. I think if there's only a couple of answers, you may have findings to those. But if there's more than a couple of answers, you probably would go a different approach to representing the answers. There was a question here on negation.
Yeah, but related to that, I think we should wait with that question until the last part of the session, because we cover it a bit in the last presentation. There was one question about what do we do in case, what our recommendation is if you have a list, you have maybe a selection list of a few values. What do you do in the case where the clinician can't find the value he or she is looking for?
Yeah.
So we do not have a specific recommendation for what to do. So this is, but it is generally a good idea to ensure that the clinician or the person doing the documentation can actually document whatever is needed. So if you have a very constrained value set and the value is not there, it's a good idea to consider the mechanisms and the processes for getting the values that are needed into the value sets, and having maybe some intermediate solution to in a free text field or whatever. But it's just so important that you ensure to have the processes in place so that the value sets can be updated, and that the free text, if you have captured the information using free text, that you associate that with the appropriate SNOMED CT content afterwards, so that you can use it for subsequent retrieval and analytics.
Yeah, I agree. Often you see free text as well as coded data, and not everything will be coded. So it depends what information you're putting in there. But free text can still be shared from one system to another in messaging. So, but yeah, if something's used often as free text and there needs to be a SNOMED code, then that can be added through requests. So I agree that it's a combination of both, and it's what's required in terms of what you need to code, why you need to code it, and how you're going to use that coded information.
Yeah, I think we should leave the questions here and then go to the next part of this session, and this is where we will give you a demonstration of a software, a demonstration tool that shows you some of these best practice principles. And those of you who have been asking about expression constraints, you will see how we actually populate value sets using expression constraints in this tool. so please be aware of that. So I will turn off my camera and leave you to the next presentation. Please enjoy.
Now I'm just going to show you this piece of software which has been developed to demonstrate the principles that you have just heard about in the presentation for using SNOMED CT for data entry and searches for data entry. So the purpose of this tool is also to show you an example of how SNOMED CT can be used in an electronic health record system and how it could look like in a clinical user interface. This tool consists of a set of user interfaces, and the one we are looking at here is the user interface for patient details. So this is a user interface where you would enter the name, the date of birth, the gender, and other demographics and patient history information. Then we have the encounter user interface, which is where you would document the reason for an encounter, the diagnosis, and any procedures. There's also a user interface for allergies and adverse reactions. So this is where you would enter the substance that is the cause of an allergic reaction, the criticality, and any manifestations. Then we have a set of placeholders over here for additional user interfaces, but they haven't been implemented as part of this demonstration tool. In the bottom here we have the patient summary, and this is where the information that has been captured in the other user interfaces will be shown. So like giving a summarized view of the patient. But if we jump up to the patient details user interface again, I just want to show you how this tool indicates that it's actually a SNOMED CT enabled system. And we can see that some of these controls has this icon with an S, the gender here, the smoker type, and the smoking status. And this S icon indicates that the specific field or control is using SNOMED CT to document its values. For each of these SNOMED CT enabled controls, we have this additional icon, the eye here, and this can be used to see details about how the specific control has been bound to SNOMED CT. So if we click on this smoking status here, we can see 3 values, and then if we click on the eye here, the eye icon here, we can see the details, which says that the smoking status field uses SNOMED CT expression constraint language to retrieve all options from a FHIR-based SNOMED CT terminology server. The smoking status options are retrieved here using lifetime non-smoker or current smoker or former smoker. So, as you can see up here, there is a SNOMED CT terminology server, which indicates the server that is being used to retrieve the SNOMED CT values. In this case, it's the Snowstorm terminology server, and it's the the Snowstorm implementation of the FHIR Terminology Services API. The expression constraint, as you could see it, is that 3 values are retrieved. It's the lifetime non-smoker or the current smoker or former smoker, which corresponds to the value that are available here in this drop-down. So throughout the system, in the different user interfaces, you can see that there are many fields that are SNOMED CT enabled, and for all of these fields, you can click on the eye to see how each control has been bound to SNOMED CT. But as I mentioned in the presentation, SNOMED CT can be embedded in a user interface in various ways. And now I just want to show you how each of the types of controls that we covered in the presentation are used in this system. So if I just jump back to the patient details user interface, you can see 2 examples of drop-down lists. So here we have the smoking status with 3 values, and up here we have the sex or gender value set available in a drop-down. So in each of these cases, you can see that the value set for this control is quite limited. So it's easy to get an overview of the values that can be selected, and this is why a drop-down list is suitable, because you can easily get an overview, and you don't have to scroll, and you don't have to to do additional searching to select a value. Over here you see an example of checkboxes, which we also covered in the presentation, where each of these checkboxes are bound to a specific SNOMED CT concept. When we hover over the value, you can see the specific SNOMED CT code. But you can also see that I'm not able to select any of the smoker types options at the moment. And this is because this tool has implemented a dependency between the smoking status and the smoker type control. So currently the smoker type is disabled because the default is never smoked tobacco. But if I enter that this patient is a smoker, I'm now able to say that this patient may even be both a pipe smoker and a cigarette smoker, which again is one of the benefits of using a checkbox control, is that you can select multiple options. And if we now jump to the allergies and adverse reactions user interface, you can see other types of data entry controls. We have two instances of coded text fields here for the substance and the manifestations. So these controls are where you can enter a search string, and then the system will display a set of search results in a drop-down list. So if we say that this patient has an allergy towards aspirin, and then I start to type in aspirin, you can see that as I type, the results are displayed, and as I continue refining my search string, the results are updated. This is because this coded text field apply the technique that we talked about, real-time searching, which support effective identification of the correct concept. So now we see that aspirin is shown as the first option, and this is also because the other technique that is applied is the shortest matching term first. So it's the term that matches the shortest term that matches the search string that are displayed in the top of this list here. So now I can select aspirin. And if I look at how this data entry field has been bound, we can see here that the value set is any subtypes of the concept substance or any subtypes of the pharmaceutical biological product. So what this means is that in this search field or coded text field, the values that are displayed here are all either substances or subtypes of pharmaceutical biological product. So there's no option to use a clinical finding or procedure code in this control, because these values wouldn't be relevant for this context. So then we also have an example of radio buttons, and similarly to the checkboxes we saw before, each radio button here is associated with a SNOMED CT code, and as opposed to the checkboxes, we are only able to select just one of the values here in these radio buttons, and that is useful because for each adverse reactions or allergy, there's only one criticality. Down here we have another example of a coded text field, but here it's the manifestations. So if we can just look at first how these are bound, you can see that it's any type of clinical finding. It's the subtypes of clinical finding. So let's just try to type in aspirin as we did before. You can see that now it's the finding allergy to aspirin or aspirin overdose that are available, and not aspirin as we had before. But here I want to document the manifestations. So let's say this the manifestations for this patient is that the patient get an abdominal pain or pain in the abdomen. I can then start to write pain in abdomen, and what the system now returns are these values: abdominal pain, abdominal wine pain, and so forth. So what you can see here is that the text field or coded text field apply the technique that we talked about, which is the word prefix any order. So where the results display matches on any order of the search string. So now we can select abdominal pain, and there may be further manifestations such as headache. And in this coded text field we are able to enter as many manifestations as is relevant for this patient. So if we take a look at this encounter user interface, this is where you can document the reason for encounter, diagnosis, procedures, and they are all using the coded text field as we saw before. And there's also a drop down for laterality, and this drop down is currently disabled because it's associated with the procedure control. So let's just try to enter a procedure, and if we say appendectomy, that this patient had an appendectomy or an excision of the appendix structure, we can see that the laterality drop down here is still disabled, and that's because the appendectomy concept in SNOMED CT is defined with the procedure side of the appendix structure, and the appendix structure is not lateralizable. You don't have a left or right appendix structure. If we instead said excision of liver, liver excision, you can see that the same thing occurs. We're still not able to specify laterality. Again, we don't have a left or right liver. Let's then try to say kidney excision. You will now see that we are able to go into the laterality field and specify left or right. And that is of course because we have a left and a right kidney. So in this situation, it makes sense that you're able to specify the laterality. In SNOMED CT, there is a reference set or a set of concepts that is called the lateralizable body structure reference set. And this reference set includes all the SNOMED CT body structure concepts that can be lateralized. So kidney excision has a procedure side of kidney structure, and kidney structure is one of the lateralizable body structures in SNOMED CT, which is why this association can be easily implemented. The last thing I want to show you is how the system can actually pre-populate fields using the SNOMED CT model. So if we now entered a procedure which had a laterality specified, so that could be a CT of left lower extremity as we have it here, you will see that when I select this concept, the laterality updates automatically, and that is because the procedure side of this concept here is the left lower extremity. So the lower extremity with the laterality of left. So based on how CT of left lower extremity has been modeled in SNOMED CT and defined, the system is able to derive the laterality for this concept, and as you can see, it's disabled because we are not able to specify that this is has the laterality of right, because you can't have a CT of left lower extremity with the laterality of right. So in this way, the system is able to use the SNOMED CT model to ensure that the data is captured accurately. And the dependencies between some of the controls that you have seen here also supports effective data capture, as for the techniques applied for the coded text field, where we have the word prefix any order and the real-time searching. So So I hope that you can see how some of the techniques that we talked about in the presentation can be applied in a system to actually support the documentation process. If you'd like to learn more about the SNOMED CT UI demonstration tool, please visit SNOMED International's GitHub repository. You can access the GitHub repository using this URL, and on this site you can access the UI examples by clicking UI examples in the table here. You may also access the UI examples using this URL directly. So please go ahead and explore, but also be aware that the tool has been developed for demonstration purpose only.
Hello again, everyone. So that was just a brief demonstration of the user interface that has been developed to show some of these best practice principles. And there are more features in this tool that we just didn't cover. This was mainly to show you how these different controls that we talked about in the first presentation, how it would actually look like in a user interface, and also show you how each of those fields could be bound to expression constraints. So I hope that you enjoyed that. So Ian, do we have questions that we should cover here?
Does one question come through on querying the information stored in regard to allergies?
Maybe we should wait with that until, as with the negation question we had before, because last presentation that I'm covering here is on storage and retrieval. So maybe some of the things will be covered there, and otherwise please feel free to ask more questions on that if there's something that isn't covered.
Yeah, and you always have the opportunity to send a question into elearning@snomed.org if you feel there's a question still outstanding. So yeah.
So that was the first part of this tutorial, where we have been focusing mainly on data entry. So let's now start the session or the presentation on storage and data exchange, and I hope that you will get some of your questions on that answered. So let us just jump to the next one.
In the first part of this tutorial, we have explored the ways in which SNOMED CT can be used to capture and display clinical data. Now we're going to review other aspects of SNOMED CT in the electronic health record. More specifically, we will explore some of the best practice principles for the storage and retrieval of SNOMED CT data. Let's first look at the general best practice principles for storing data with SNOMED CT, and afterwards I will dive into a few examples. As we talked about in the first part, constraining data items to specific value sets or specific concepts should be done to ensure that the recorded concept semantically reflects the situation. It's important to always store the concept identifier for the captured concept. This is the primary identifier for the captured concept, and this is required for interoperability and analytics. However, the concept identifier only references a concept, and indirectly the concept's clinical idea. The concept identifier in itself does not hold any information about what the user interface showed when the author selected that concept, and therefore the display term or interface term for the given value needs to be stored in addition to the concept identifier. There are many alternatives that technically can be used for storing the information which was displayed for the author, but legislation or policy might require that a specific solution is used. Furthermore, regardless of how you choose to store SNOMED CT concepts, it's important to have consistent models for structuring information of similar types. For example, the structuring of absent findings. And it's important to also have a consistent way of using SNOMED CT in those models. And therefore, it's very important to apply good modeling practice. The challenge we have in terms of representing information consistently is that the same idea can be expressed in different ways. As you saw earlier, the use of SNOMED CT to capture clinical data can be done in many ways, and there is no rule to the types of controls which should be applied. This flexibility is important to meet user requirements and user preferences and work processes. However, the consequence is that different user interface designs or interface models can be used to capture the same information. And if data is stored based on the way it was recorded, it's difficult to answer simple questions. Here is an example of the same idea being expressed in different ways. 3 hospital systems each allow the user to record the clinical idea for suspected lung cancer. At Hospital A, the doctor enters a condition or diagnosis of cancer, a body site of lung, and a status of suspected. At Hospital B, the doctor enters a problem of suspected cancer and a location of lung, while at Hospital C, the doctor enters the fully pre-coordinated concept suspected lung cancer in a single diagnosis field. When it comes to querying over data from all 3 hospitals, we find that just standardizing the information model does not completely standardize the way in which the data is recorded. Because although all 3 models may apply the same information model, which allow for the recording of the condition name, body site and status, it may be that these data items in the information model are not applied consistently. The table here exemplifies how this data could be stored if it was stored directly as it was entered. Now consider this question: does the patient have a suspected lung cancer? Answering this question requires many checks to be made. For example, by checking if the concept suspected lung cancer has been recorded, or if there is a record of suspected cancer located in the lung, or if there is a record of cancer located in the lung with the status of suspected. And this is just a very simple example to illustrate why storing data based on the way it was entered makes it difficult to query and analyze it. The principle for storage, therefore, is to ensure that the values are stored consistently for all required elements of the information model that will be used for subsequent retrieval. In the next set of slides, I will show you an example of how to ensure semantic consistency at a storage level by using the definition of SNOMED CT concepts. First, consider the value set bindings for the information model applied in the 3 hospitals. The condition data element is bound to the set of subtypes of clinical finding. The body site data element is bound to the set of subtypes of anatomical or acquired body structure, and the status data element is bound to the set of subtypes of finding context values. When the user selects the value cancer, the SNOMED CT concept for malignant neoplastic disease is stored in the record. And when the user selects the value lung, the SNOMED CT concept for lung structure is stored. And similarly, when the option suspected is selected, the SNOMED CT concept for suspected is stored. In Hospital B, when selecting lung in the body site data entry control, As for Hospital A, the SNOMED CT concept for a lung structure is stored. But when selecting the value suspected cancer, this does not mean that the SNOMED CT concept for suspected malignancy is stored. As you can see from the semantic tag, this concept is a situation, and therefore not a subtype of clinical finding, which is required according to the binding of the condition data element. However, we can derive the appropriate clinical finding concept to store based on the definition of the concept suspected malignancy. As shown here, the associated finding of this situation is the disorder concept malignant neoplastic disease, and the finding context is the finding context value of suspected. These concepts can therefore be stored to be consistent with the information model while retaining the intended semantics. In Hospital C, when entering the condition suspected lung cancer, we also need to derive the appropriate values to store, which again can be done using the defining properties of the selected concept, in this case the concept suspected lung cancer. As shown here, this concept is defined with an associated finding of malignant tumor of lung. This concept is within the scope of the condition data element, and can therefore be stored. And as before, the finding context value to store is the finding context concept of suspected. To store the appropriate value for the body site data element, this can be derived from the definition of malignant tumor of lung, which has a finding site of lung structure. So as you can see from this summarized view, using the defining characteristics of SNOMED CT concepts, it's possible to obtain consistency at a storage level, although the user interfaces are very different. And now you may notice that the concept used to store the condition is different for Hospital C. However, if we look at the SNOMED CT hierarchy, we can see that malignant tumor of lung is a subtype of malignant neoplastic disease. So queries for types of neoplastic diseases will also include the concept malignant tumor of lung. If you want to avoid this situation, a recommendation is to apply the modeling principle that no overlap should occur between values captured in the different data elements. Here I just want to make a few points in relation to enabling the effective retrieval of SNOMED CT content. Because using a terminology server is the best and most efficient way to implement a terminology in an electronic health record system, to support key tasks such as data entry, clinical decision support, reporting and querying. Terminology services are functions performed by software that interacts with one or more representations of a terminology to provide access to information derived from that terminology. And using services for specific terminology tasks also follows the industry-accepted practice of adopting a service-oriented architecture in systems design. When working with SNOMED CT-enabled health records, the best practice principle is to use a terminology server with services that are designed to utilize the design features of SNOMED CT to achieve powerful health record functions, and furthermore to apply regular updates to ensure that the enhancements made to the terminology are reflected in the health records. While there is significant commonality between the terminology service requirements of different terminologies and code systems, there are also differences that relate to the design of the terminology. So if you plan to develop or to use a terminology service with SNOMED CT, it's important to design or select a service that takes advantage of the specific features of SNOMED CT. For example, services that support searching SNOMED CT content, including term searches and searches over multiple synonyms of the same concept. and searching content in specific hierarchies, or based on defining relationships. Other important services include services that support the retrieval of data about specific concepts, such as the descriptions associated with the concept, or supertypes or subtypes of concepts, or the retrieval of the concept's defining properties. Furthermore, important services to support the use of SNOMED CT in health records are services which support SNOMED CT queries based on stored health record data, or services which enable accessing maps to or from SNOMED CT. Let's just briefly explore how terminology services relate to the design of electronic health records. As shown in this slide, an effective way to design an electronic health record is to separate the terminology services from the record services. Using this architecture, the role of the terminology services is to manage the terminology-specific tasks, while the record services use the terminology services to manage the health record tasks. As shown on the left of this diagram, key terminology services are based around a data store of SNOMED CT resources, including concepts, descriptions, relationships, and reference sets. On the right-hand side, you can see that SNOMED-enabled record services are based around a data store of patient health records that contain SNOMED CT codes. Key terminology services in an electronic health record system include installing and updating the terminology, searching for terms, querying, and getting map data. These services are then made available to other applications through an application programming interface, or API. The API allows programmers to access the key services without being affected by changes to the way these services are implemented. Each record service is then able to call one or more terminology services to support the required functionality. For example, a search and retrieve record service may use the search terms terminology service, and an enter data record service may use the search terms and query terminology services. A query or extract record service may use the query and get map data terminology services, and a communicate record service may also use the query and get map data terminology services. In the last part of this presentation, I will make a few comments regarding the use of SNOMED CT to exchange data between systems and applications. Critical to the success of electronic health records and the general digitalization of health information is the ability to share and exchange data between different data sources. Whether it's about sharing data between and across hospitals, clinics, registries, or devices, effective mechanisms to exchange and interpret data is important to increase the quality of care, enable data analytics and research, and many other significant purposes. Data exchange requires a certain domain-independent format that can be used to represent the data. Such formats have evolved from being markup and display-oriented to further support the encoding of metadata that describes the structural attributes of the information. Some of the non-standard formats are better suited for data exchange than others, because their specification is driven by a formal process instead of particular software implementation requirements. Examples of widely used formats for data exchange include XML and JSON. There may also be dedicated APIs developed to support the exchange of clinical data. There are also standards developed with the objective to enable effective exchange of clinical data. HL7 is a non-for-profit organization dedicated to provide a framework and related standards for the exchange, integration, sharing, and retrieval of electronic health information. HL7 has developed different standard documents and frameworks for exchanging healthcare information electronically, here among HL7 FHIR. The basic building blocks in FHIR are called resources. Each resource includes the information recorded about a single clinical idea, and then the resources are combined using a compositional approach. Here is an example of the FHIR condition resource, which is used to record details about a clinician's assessment and assertion of a particular aspect of a person's state of health. This resource includes a number of value set bindings, which are recorded in a table associated with the resource. In this table, you see 3 of those terminology bindings. Each binding has a path to the data element in the model, a definition of the data element, the type of binding, and a reference to the value set being bound. For example, in this case, the code data element from the condition resource is being bound to the condition code value set, which has values within the set of subtypes of clinical finding, or the concept no current problems or disability. In the same way as we saw in the example earlier with hospital A, B, and C, SNOMED CT is bound to the relevant and specified parts of the information model. And in this case, the binding between the coded data elements in the FHIR resource and specific SNOMED CT value sets form the basis for effective semantic interoperability between healthcare systems. This brings me to the end of this presentation. I hope that you now have some more insight to the role that SNOMED CT can play and the different approaches to enable SNOMED CT in the electronic health record. Thank you very much for listening.
Thank you very much for listening. So that was the last of 3 presentations in this session. And I think I will just summarize one of the main points with this last one, relating to both storage and retrieval, and that is the point of being true to your models, the models you use, the information models and the terminology model. So it's very important that regardless of how you choose to capture data at the storage level, you are using a model and you have consistent ways of binding to those models. And the same thing occurs when we talk about exchange. You use a specific model or representation of the data that you want to exchange, and at the point of implementation, you should consider, well, how is our data that is captured? How are we ensuring that these are stored in alignment to the models we use for storage, exchange, and queries, and so forth? And sometimes that may even require different representations of data at a storage level. So there's no one saying that there's only one way of storing data. Maybe you have an expression or a repository you use for retrieval, and the other one you use to store the patient data in another manner for another purpose. But being true and consistent in the way that you use the models and the terminology in a combination is essential. Ian, do you have something to add on that?
So I think Sarah had asked about separation of expression data. So I think that's really covered that, hasn't it?
Yeah, that's my point.
Yeah, definitely. So the other question come up is people would like the slide deck for this, or someone else asked, could they review the presentations again? So the presentations will be available for 3 months on this system, so you will be able to go back and have a look at the presentation again as a video. In terms of slide decks, I think if you want to put a request in, I think you'd be happy to share those with people.
Yes, certainly. But we could also say that many of these topics that we have covered here is available in our SNOMED courses, but also on our e-learning platform in the freely available presentation library. So it's not exactly the same presentations, but the topics are covered in different presentations there as well. So that may be useful for you. Earlier we had the question on negation. So I hope that you feel that was covered in this last part. So where I was showing an example of an information model for storage. So in the finding context, you had that status that was linked to the finding context values. In there, it could be, you could also have a similar model where you represented the absence of a finding. So instead of it being a procedure, you could have a model for a clinical finding, and then you could have a status field that was linked to absent or present to indicate whether a specific finding was absent or present. So there are those ways of again, it depends on the model you're using, but modeling your data in a way that allows you to use the SNOMED CT qualifier values to represent absence or presence and so forth is a way of dealing with that.
Yeah, and I think the majority of the time you want to say what is present in a patient and not express all the things that are not present in a patient, because that could be a long list of all the things the patient doesn't have. So I think negation is a specific use case for certain times where you have to say a patient doesn't have something. But I don't think there's a point in having a negative to every concept within SNOMED. I think generally the view is you should record what you know about a patient, not what you don't know. But in certain cases, you need to put in certain negation concepts. And as Anna said, that can be done in the information model or as a pre-coordinated concept. And there are variabilities on that approach within vendor systems.
There was also a question earlier on if you are documenting and you use SNOMED CT expressions for storage, there is a risk of having inconsistent way of storing SNOMED CT expressions that will then complicate retrieval. And I agree that is a risk. If you work with the post-coordinated expressions, again, it's important to have that analysis in the beginning of how do we store, so that we ensure that even though it's expressions, how are they stored consistently, and then in order to query those expressions together with the pre-coordinated concepts that you may also be using in your system, that requires that you are able to classify your expressions in the same way as we do with pre-coordinated content. So normalizing and transforming the expressions into a normalized form where you can then use it for retrieval. We are currently at SNOMED International working on further guidance on post-coordinated expressions. So I will recommend that you keep an eye open for new documents within the next year. There will be more guidance on post-coordination and the use of expressions as they are in working process as we are speaking. Are there more questions, Ian?
There's a question about, do qualifiers need to be constrained by the concept model? So I think in those cases, to be able to exchange from one system to the other, we would recommend that you follow the concept model in terms of what qualifiers should be used. I think there is expansion in terms of post coordination. Am I right, Anna? That sometimes that it's less strict on the concept model for post coordination.
Well, yes, you're right, Ian. And generally, you can say, well, without knowledge about the context and associated meaningful concepts, a qualifier can be very meaningless, because it can be a concept like yes and no, and yeah, there are so many different types of qualifier values. But you need, in order to interpret qualifier values, they need to be in a context of a concept, or in a context of a specific data entry item in a field, and possibly also other data items. So using qualifier values on its own is seldom a good idea. It needs to be in a specific context with other concepts and models.
So I think you've answered all the questions now, Anna. So
that's great, and we're still a few minutes ahead of time. So I will give you back 3-4 minutes of your day, and I'm very pleased that you attended this session, and I hope that you will, if you have any questions, just send us your questions at elearning@snomed.org. Thank you, and bye-bye.